Welcome to The Explainer. Today, we're demystifying exactly how to build a highly secure, completely HIPAA-compliant fortress around your healthcare AI. Whether you're building AI scribes or diving into patient analytics, mixing the power of large language models with strict healthcare privacy laws can feel pretty daunting. But honestly, it doesn't have to be. Let's just address the elephant in the room right up front. $2.1 million. That's the potential maximum penalty for a single HIPAA violation category in a single year. The stakes for getting this wrong are absolutely monumental. And we aren't just talking about financial hits. It's about patient trust, your reputation, and the literal safety of electronic protected health information. When you start throwing generative AI into the mix, models that can inadvertently memorize or hallucinate sensitive data, security has to be your absolute #1 priority. But hey, don't panic, because we're laying out the exact 6-step blueprint to safely deploy AI without waking up in a compliance nightmare. We're going to cover executing BAAs, setting up private networks, de-identification and guardrails, enforcing technical safeguards, audit logging, and finally, the human-in-the-loop workflow. Let's jump right in. All right, step 1, the foundation, executing business associate agreements. Before you even think about writing code or sending an API request, you need a signed Business Associate Agreement, or BAA. Look at Azure OpenAI Service versus the standard OpenAI API. Azure gives you that required BAA for clinical workloads, meaning they legally commit to safeguarding the data. The standard OpenAI API, no BAA offered at all, which instantly disqualifies it for regulated healthcare. It doesn't matter how fast or smart their newest model is. If they won't sign a BAA, you simply cannot use them for EPHI. Your compliance needs literally dictate your architecture. Moving on to step 2, the moat, setting up private networks. Even with that legal foundation in place, you absolutely do not want highly sensitive clinical data traveling across the public internet. This is where you bring in network infrastructure services like AWS Private Link or Azure VNet. When your application asks the AI model to, say, summarize a clinical note, these services route that request and the response entirely within a private, isolated network. The data never sees the public web, giving you a rock-solid architectural moat. Step 3, blurring the treasure, data de-identification, and AI guardrails. If the AI never sees patient identifiers, it can't leak them. It's that simple. Under the HIPAA Safe Harbor method, there are 18 specific categories of identifiers you have to scrub. We're talking names, contact info, exact geographical data, and notably, dates. You have to strip exact birth or discharge dates down to just the year. And for medical record numbers, you've got to use hashed pseudonyms instead of the actual IDs. No full face photos or biometrics either. But static scrubbing isn't quite enough, right? You also need active guardrails, like Amazon Bedrock guardrails. These act as active filters to detect and redact stray PHI on the fly in both inputs and outputs. They block malicious prompt injection attacks, and, critically for healthcare, they provide contextual grounding. This evaluates the model's response against verified source documents, strictly blocking dangerous clinical hallucinations, like a fabricated medication dosage, from ever reaching the clinician. Next up, step 4, the locks, enforcing strict technical safeguards. With the data blurred, we need to bolt the doors. You must have AES 256 encryption for data at rest and TLS 1.2 or higher for data in transit. You also need role-based access control, or RBAC, ensuring least privileged access. Basically, a billing specialist should only see billing data, while a physician sees the full clinical picture. You'll tie all this together with a key management service to rotate cryptographic keys safely. And you absolutely, positively cannot skip multi-factor authentication. To really ground that last point in reality, the massive Change Healthcare breach exposed over 192 million records, and it was enabled specifically by the absence of MFA on a remote access portal. MFA isn't just a best practice anymore. It is a strict, non-negotiable mandate for any system touching EPHI. Period. Okay, step 5, the watchtower, building comprehensive audit logs. So the fortress is secure, but you need security cameras monitoring the inside. And there's a huge difference between baseline compliance and actual security operations. The compliance minimum just checks a box for auditors, who handled the PHI and when. But SecOps logging gives you the real context. If your API costs suddenly spike 300% overnight, robust logging empowers your team to instantly investigate that anomaly, figure out which system caused it, and respond. And keep in mind, HIPAA mandates that you securely store these audit logs for a minimum of 6 full years. They have to be immutable, meaning nobody, not even a top-level admin, can alter or delete them during that time. Cloud tools like Amazon S3 Object Lock and Compliance Mode are practically tailor-made to hit this exact requirement. Finally, we've arrived at step 6, the commander, the human-in-the-loop workflow. No matter how advanced this tech gets, it's ultimately just a tool. Generative AI is fantastic at rapidly drafting clinical notes or suggesting billing codes, but the ethical and legal accountability never leaves the healthcare provider. AI scribes do not shift responsibility. Mandatory human review is an absolute necessity here. The provider has to review and verify all AI-generated documentation before signing off, and your architecture needs to make that review process as seamless as possible. So as you design your secure healthcare AI architecture, I want to leave you with this final thought. Is your technology serving as a shiny new replacement, or is it an impenetrable, compliant tool designed to actually empower clinicians? When you build following this blueprint, your system fiercely protects privacy, so the humans in the loop can finally focus entirely on the patient. Thanks for joining me on this explainer. Until next time, keep building securely.